We are coming to you from Toronto and New York and Baltimore and the beach and Brazil and all over the world, London, Guatemala City. So thank you for joining us, and we have a lot to talk about today. We have some great guests today. We have Deborah Diaz, and she's in New York. She is my boss. So shout out to Deborah. We wouldn't be having Space Apps without her. So you guys give her lots of Space Apps love, and she's in charge of all the digital strategy and open innovation that's going on at NASA. So we're going to hear from her. Right next to her is Doug Wheelock. So hello, also in New York. Doug is an astronaut. You couldn't tell it by what he's wearing, but he has 178 days in space. And so he's here to talk about, oh, he's taking a picture of the Google Hangout. All right, with his iPad. I'm sure it's government. Oh, that's a great picture. Awesome. So Doug is kind of Mr. Fix-It in space. He went up on STS-120, which is a shuttle mission. He and Paolo, who I'll introduce next, went up to space together. And while they were there, we had one of our harrowing missions with a problem with the solar panel, a solar array that did not deploy. So we had a MacGyver moment, had to fix a little cufflink. I'll let you talk about it later, but you know, there's something about going to space with Doug. There seem to be problems. He also went to space station on expedition 24 and 25, and during the 24 mission, pump module failed. He had to go do an emergency spacewalk with that, and then he became commander of of expedition 25. We have Paolo. I don't see him on. When he does join from Brazil, he was also a crewmate of Doug on STS-120. And for all you girls and women out there, their commander was a woman, Pam Milroy. So you can always tell about the crew by the commander that they have. And they had an awesome crew they had great camaraderie. And I think that's just, you know, we do that well, you women out there. Also, Paolo had 174 days in space. He was up on expedition 27, 28, I believe. He has the privilege of having spoken to the Pope from space. So you can ask him about that later when he is connected somewhere. He was connected earlier. We also have Ellen Stofan, who is our NASA's chief scientist. She's coming live from the beach. She's having an awesome day off on a Saturday. Imagine that. She is our, she's a geologist, a planetary geologist, so she likes rocks. So those of you who like rocks, you know, she's the person to talk to. She happens to have a few favorite planets, and you can correct me, Ellen, if I'm wrong, but Venus, Mars, Saturn's moon, Titan, and Earth happen to be some of her favorite rocks. So you can talk to her about that. She is our kind of chief proponent for citizen science. And that's really a new thing that we're trying to do more of. We can ask her about that. And then we have Jason Kessler coming to us from Baltimore. And Jason is our asteroid wrangler. He's in charge of the Asteroid Grand Challenges, so he's got a lot to share with you. And you have a lot of challenges that you guys are working on with asteroids. He also is taking over the leadership for one of my favorite programs at NASA. It's the Launch Program. It's a challenge program we have with USAID, State Department, and Nike, and he's taking over that, and we wish him well for doing that. He also, I don't know that I should say this, but I will, he also is one of the hottest bachelors in DC, and you can look it up. I didn't make that up. He actually is. Jason, you can pose if you want to. So welcome, Paolo. Thank you for coming on. We've already introduced you, so you have no idea what I said. So I made up great things about you. So thanks for joining.
Thank you.
We also have Guatemala City, if you guys can wave.
Indeed.
Awesome. And we have London, Claire and her team, if you can wave. And we'll have a few questions from New York from the crew as well. So let me just jump into introductions. So Deborah, if you can just say a few words of introduction.
Well, thank you all for coming. I know that we've kicked off pretty much around the world. I think we might still have one more time zone. But I'd like to actually offer this up for each of the different locations We had a great session this morning, a very interactive session with our STEM students. And we've got folks, a lot of folks here who have been really busy since about 9 o'clock this morning, and some great questions, a lot of discussion about health sciences, and a lot of use of big data. So a lot of things to work on here, and I'll turn it over to my colleague if he wants to talk about a few things.
Hi guys, I'm Doug Wheelock, Astro Wheels, and great to see you, Paolo, and great to see everybody around the world. We're ready for your questions, and we've got an exciting day celebrating International Space Day, and Yuri's night tonight as well, so welcome, and let's get going.
Thank you, Beth.
So let's go to you, Paolo, since you joined us a little late. We'll come to you next to just say a bit of welcome.
Yes, good morning, good night, good evening, good whatever to everybody. I'm in Brazil, first time in Brazil at the Polo Universitario de Campos de Goitacazes. I hope I got it right.
For you to
yeah, because they invited me here, they said, do you want to come to Rio? And I said, yes, and now I am in the middle of nowhere. But it looks really good, and it's very interesting, and I'm really looking forward to talk a little bit about the global challenge and the space apps and all we are doing here. All very exciting. Thank you.
So let's jump to Ellen.
Hi, everybody. As she said, I'm the chief scientist at NASA, and I'm a planetary scientist, and I know from doing that how important teamwork and collaboration are. And this is my first International Space Apps Challenge, and to me, it's such a great example of how working together we can accomplish so much. I'm particularly interested in the Coastal Flooding in Your Community Challenge. We're very focused right now on planet Earth at NASA. We have actually 5 launches to planet Earth. We've already had one successful one back in February. We're really excited about taking all that data that we collect at NASA and finding ways to get the public involved to help better understand our changing climate, and especially, again, in coastal flooding zones. We just announced something a few weeks ago called the Climate Data Initiative, which is at climate.data.gov, which takes a lot of our data, and not just our data, but all of the data from across the federal government, and brings it in one place to help people really start using that data to better understand the challenges facing our coastal communities. So I'm excited to be here. So much going on today, and I can't wait for your questions.
Thanks, Ellen. How about you, Jason, Mr. DC?
Thank you, Beth. Hello, everybody. Greetings from the Baltimore, Washington area. We've got a great group of participants here. I am the Asteroid Grand Challenge Program Executive. It's an opportunity to accelerate the work NASA's already leading in finding hazardous asteroids. And Space Apps is exactly the kind of place that we are excited to be, because we have 12 asteroid challenges that we had fantastic responses last year, and looking for new ideas to help us prove that we are smarter than the dinosaurs.
Awesome. So welcome, everyone. I want to also thank the Ontario Science Centre that's allowed us to host this here. You guys are great for giving us a wonderful venue. And I know you guys are all working hard. They're all around me. Can you just give a shout out? Can you yell and scream, welcome from Toronto? All right. Oh, well, there goes the camera. It's going to give you a the centrifuge motion to get around there. So that's can you see us? There we are. Okay, so let's just jump into questions. We've got a lot of them. I'm going to start with Deborah. Right now we're engaged in collaboration and problem solving with citizens around the world. So what value does NASA get out of asking the citizens to come in and solve our problems?
A lot of the value is just really the new thought. It's the citizen engagement that we talked about, and it's really focused concentration and dialogue globally. All of these data sets can be seen in a different way from individuals, and whether it's software, hardware, whether it's a visualization activity, or whether it's working with other agencies, like Ellen was talking about with the climate initiative, there are so many things that the general public can add to the work that we are doing here at NASA. And we have lots of challenges, and we've put up 65 for all of us to be focused on right now for this Space Apps Challenge.
Thank you, Deborah. And since Doug's right next to you, it's the Deborah and Doug show. We're going to jump to you next. We have a question. I'm going to ask Paolo to answer it as well. But we have a question from Spaceman 1969. He wants to know, what does it feel like to take off of the Earth and land back on the Earth? And I know that there's a difference between your vehicles, so feel free to expand on that.
Paolo, do you want to go first?
Well, only if I have a couple of hours for this question. So
Well,
just go ahead.
Yeah, I'll jump in real quick, because actually Paolo and I launched together on the space shuttle, so we both have the sort of the unique experience of being able to take off, launch in a space shuttle, and land like an airplane on the runway at Kennedy Space Center, and re-enter the atmosphere as well. And then it's an entirely different experience on the Russian Soyuz. And so actually the launch sequence on a shuttle is much more dynamic than on a Soyuz. And then it's the other way around, coming back through the atmosphere. The shuttle is pretty smooth coming back in through the atmosphere and landing essentially like a glider on the runway. But coming back in the Soyuz is sort of like going over Niagara Falls in a barrel, and the barrel's on fire. So go ahead, Paolo.
No, this is a very good description, Doug, and I fully agree with everything. I think the question was also addressing the point of, at least this is how I understand it, addressing the point of, you know, a human being going to space and needing to become an extraterrestrial person. You know, the body is not really used to that, and it takes quite some time before you can really actually fly and be effective in space. And it's a very amazing experience. Microgravity, it's amazing. Looking at the Earth from out there, it's pretty amazing. And then, you know, eventually you go back again to Earth, and you need to become again a terrestrial person. And I can assure you that gravity has such a heavy-duty pull on us, and we don't understand it, but it's like somebody put on me a 300-pound blanket, and I was trying to move through this thing, and but this is the feeling. So I'm really looking forward on the time when people can actually fly in space and experience all of those things, because they're pretty amazing.
Thank you, Paolo. Let's jump now to Ellen. What is the role of citizen science in furthering NASA's scientific research and exploration?
You know, I think we're just on the verge of a revolution when it comes to citizen science, and part of the reason it's so important right now is that NASA is now really successful at gathering really large data sets from the Hubble data that we have, looking deep into the universe, you know, gathering data on lots and lots of galaxies that citizens right now are helping us classify. They're helping us classify stars to say, do they have dust around them? So are those good candidates maybe for stars with extrasolar planets? Citizen science is helping us wade through all the Mars data that we have to help understand the ages of different units, help map Mars. So in all of those areas, citizens are coming together to help us with this, again, this massive amount of data, and we really need their help. And so it's a real science experience for the public, and it helps us get through our data. And then, as with some of the challenges here today, the data that we have of planet Earth are really important for trying to understand our changing climate. So the more we can get the public involved and the more we have that data be useful, I think the better decisions we're going to make about how to deal with climate change.
Thanks, Ellen. So Jason, I see you dropped off for a second, but you're back. We're going to jump to you now and ask, what are NASA's plans to explore asteroids, and what, if any, citizen or private companies plan to fund projects to mine asteroids? Kind of a two-part question.
Okay, so when we announced last year the budget, we announced the Asteroid Redirect mission, a really exciting mission that NASA has to send a robotic spacecraft to capture an asteroid. One idea is with a bag and redirect that asteroid to a lunar orbit, and then send humans on the SLS Orion to visit that asteroid and bring a sample back. Another plan, alternate concept, is to send the robotic spacecraft to a larger asteroid and pull a boulder off of it and move that boulder asteroid into a lunar orbit and send humans for samples. So NASA's got plans in the works to bring samples back with humans in the early 2020s. Additionally, there are 2 real live mining companies that exist today. And in fact, NASA has a Space Act agreement with one of them. Planetary Resources and NASA are working to do some better algorithm development for asteroid hunting. And Deep Space Industries, the other mining company, has been an active participant in a lot of our brainstorming. So, in fact, there are 2 real live mining companies that plan to mine asteroids.
Awesome, thank you. I'm going to jump to an astronaut question because we have so many, and I know Doug has to leave a little early. I'm going to address this to you. Did you bring, okay, that's a different one. All right, how does the body react differently in space than on Earth? This is from Kristen in Brooklyn. And then I know specifically you may want to talk about eyesight. Doug?
Absolutely, and I will be with you through the whole Google Hangout.
Right.
But okay, so adapting to space, Paolo hit a little bit on it. When we go to space and the gravity switch is turned off, and everything is floating around, and your body takes a little bit to adapt, although it does adapt rather quickly. But when we first get to space, we have to relearn very, very simple things. How to eat without things floating around, how to drink out of a straw without things continuing to come out of the straw, when usually gravity pulls them back down into the container that they're in, how to brush your teeth, how to go to the bathroom, how to clean your body. You know, so there's all these very, very simple tasks that the first couple days in space, the spaceship is not the cleanest place as we relearn to do these tasks, and then of course the body adapts relatively quickly. And as Paulo mentioned, coming back to the planet, we also have to worry about. And if you're up there long duration, like Paulo and I were on a 6-month mission, or if when we send people to Mars, they may be away from planet Earth for up to 3 years, and so we have to really consider, you know, muscle atrophy and bone density, loss of bone density, and things like this. So these are all countermeasures that we're working through, technologies that we're actually testing on the space station now to be able to. So when we have our young students that are just students right now, 25, 30 years from now, when we see them walking on Mars, they want to be able to stand up when they get there, and so those are real issues that we have to deal with, the body's adaptation to when that gravity switch is turned off. And the eyesight thing, of course, when we flew in space, we were all kind of told, and everybody sort of physiologically reacts individually in their own way. Sometimes you feel a little nausea. You can feel a little dizzy. You can feel like vestibular kind of balance problems. One thing that I noticed, my eyesight changed a little bit, and I don't think we're really just kind of learning about this at NASA now and trying to get our arms around it. And it's the body's way when we get to space. There's some fluid shifting, so the body pretty quickly recognizes that you really don't need your legs anymore. And so it starts pumping fluid upstairs to protect your brain. And sometimes this pressure inside of your head that your body is using as a sort of a defense mechanism in adapting to space, sometimes that pressure stays elevated and it can push on the back of your eyes. And so we're learning this is sort of a new phenomenon, and we're learning ways that we can mitigate that. And so when that pressure, if it stays for a long period of time, say 6 months, and you come back and then the pressure relieves and your eye, the back of your eye comes back into shape, it can leave little folds on the choroidal layer, which is behind the retinal layer of the eye. And so we're just now really beginning to study this and how vision will be affected by long-duration spaceflight. So a lot of physiological questions we need to answer before we launch a rocket to Mars. And this is what we hope to get out of this challenge as young engineers and scientists who love studying the area of life sciences and countermeasures and things like that, and especially in the medical field. We're really anxious at NASA to see innovation.
Thank you, Doug. Paolo, we're going to jump to another astronaut question, and I think this would be a good one for you. For some reason, I think it will be a fascinating answer. I'm curious. After you spend extended periods of time in outer space, do you dream differently when you're living in zero gravity, and what happens when you return to Earth? And this is from Con in Philadelphia. So it's all about dreaming.
Well, I would say that people, to start with, sleep in a different way. This is very subjective. Some people can sleep very easily in space. This is me. I sleep everywhere. Some other people have difficulties because, you know, gravity even takes you and lays you on the mattress. Now you cannot even assume your sleeping position. You're floating or something. So makes things a little bit complicated. I did not see any change on my dreaming pattern, so I cannot report anything strange. But this is me. It might be somebody else has a different experience. The only thing, though, that really happened to me is that when I woke up in the morning for the first weeks, I had the clear sensation of being upside down. I mean, I would wake up and I say, what am I doing with my head down? And I was trying to turn around and, of course, making a mess inside my crew quarters. And, of course, nothing is changing because you don't have a flipping anymore. So this is kind of a strange effect of being in space.
That's awesome.
And Doug, I don't know, maybe Doug wants to add something.
No, that's very well put, Paolo. And one thing that when I came back to Earth, I actually, for a pretty long period of time, I would often wake up in the middle of the night with a floating sensation. I don't know if you felt that, Paolo, but I had that linger for several weeks, actually.
Yeah, I have to add a story because I love collecting people's stories, but I know that Mike Massimino was telling a story about coming back from one of the last missions, and he tried to pass the groceries to his wife as if he would do it in space. They all dropped on the ground. Exactly, he was passing them on, and gravity took over. Let's jump to Guatemala City, because you guys, I know, are just eager to ask a question. Can you ask one, and we'll come back to you in a minute?
Yeah, sure. We wanted to ask you a few.
And who are you asking the question for? Can you say who you're asking it to?
Oh, maybe any of them can answer it. It's like a general question.
Okay.
Okay. It's the following. What has been the most useful piece of technology you have used in space that has helped you, like, your daily life?
Okay, let's go with Doug first. What's the most useful technology in space that helped you with your daily life in space? Was that it? Is that the question? Okay.
Yeah.
Actually, probably with my daily life in space, probably the cameras that we had on board were, of course, put up there for us to test out as well. And so those were actually very useful. The exercise equipment was extremely useful for maintaining muscle strength and things like that. And so developments that we've had in exercise countermeasures were very effective on a daily basis for us up there. I was wishing that we had made further strides in the way of in the space food, but and we did have some treats from time to time, but space food is not altogether very tasty. Sometimes we would get some tasty treats that they would put in the capsule, the unmanned resupply capsules that we would open up, and we could see some fresh fruit and things like that. But primarily, I think just the things that help us to adapt, the technologies that help us to adapt in zero-G were very, very useful for us in preparing for either a long duration, and we're actually on these long duration space flights. We're actually on the space station. We're actually also trying to replicate transit to Mars or something, you know. So it's helping us understand how we can stay fit and active and engaged in what's going on around us, and understanding the technology that we're developing as well. And so I would say those are the primary technologies that were useful on a daily basis. Now, we also had a couple hundred experiments going on in our 4 laboratories on board. And so in our interaction with those experiments and those laboratories are, you know, vary anything from like turning it on and letting the ground just through telemetry get their data, or we can also, we may be the actual experiment itself, and so the experiment is on us as far as like a diet and also different varying exercises and sleep arrangements and things like that. So did I answer your question?
Yeah, thank you.
Okay.
So let's jump to Claire in London. Claire, do you have a question?
Hi, I'm Olivia. I'm from Team Journey into Space in London. I've got a question for Doug. So we're doing an app that's designed to help with documentation whilst you're in space. So I was wondering if there's anything other than audio, video and text that you would find useful to record whilst you're in space.
So it's a question about what technology or what app that would help with documentation of their daily lives, of the work they're doing.
Sure. Other than audio, video and text, so is there anything else you could record that would be useful?
So Doug, you want to jump on that first?
Sure. Paulo, do you want to chime in on that one?
Well, I very quickly, I do feel, for example, there should be if somebody would come up with an app that would record and would put a location every time we take a picture, automatic location, so that we know where it is and what it is, and we can go back and get it later easily. It would be very nice. It's not so easy in space. You take a picture and then going back and figuring out what it is not easy.
Yeah, that's a great point. There are a lot of times where I would see something beautiful and I'd snap a picture and I would have no idea where I was over the planet Earth. And normally we had a kind of a funny saying that we said, well, where are we? We're over the Pacific, you know, because it takes up so much of the surface of the globe. We always kind of defaulted to that. But Paulo, that's a great app that we could have if we could take that picture and actually give us a location over the surface of the Earth. Would be amazing.
It's a great challenge for you guys all working on your apps right now. You might have to veer into a different direction just to get that for them. You heard it from their mouths. I think Doug and Deborah have to jump off right now for something else. Is that what I was just told?
But also, I wanted to raise that we do have a challenge that's very similar to what they were just describing, and called Where on Earth. So please focus in on that. And hopefully we'll get some really good solutions from this Space Apps event.
Thanks, guys.
Yes. We do have to jump off. We've got another commitment. And
you have one student with you? Or do you have a question from a student that could jump in right after you leave? Is there someone near you?
Yes, actually, we can go ahead and maybe start with our smallest, well, not smallest, but our youngest participant in Space Apps Challenge. He's 4 years old, Sunay John. If you can go ahead and give a question to the audience.
And thank you, Deborah and Doug.
So ask your question.
What's your name?
Yeah, Doug does not remember that once in a while, so we need to.
Do you have a scientific question, maybe, for some of our scientists or our astronauts? And I think what we might do while he's thinking about a question is we're now going to go to John Roberts, who's on screen with you right now, next to me. So John, if you want to ask your question, and both Doug and I will come back. We just have about a 20-minute press conference we've got to jump to, and then we will return.
Thanks.
So I have a question for the astronauts. Doug is on his way out, but Paolo, I think you might be a good person to answer this. I know that solar weather has a large impact on electronics around Earth and also satellites in space. We've just gone through a very weird period of solar activity. I guess we're somewhere close to solar maximum right now. Does things like solar flares and large outbursts from the sun have a significant impact on life on the ISS?
So that was a question for Paolo, and maybe for
Yes.
Ellen.
Yes, exactly. I was going to say something quick and then pass it over to Ellen as a scientist. There is some effects on solar activities on station because we get bombarded with particles, and the computers on board are sensitive to this, and we do feel, we do see the particles coming to our eyes and flashing here and there. But in general, I mean, besides those relatively minor discomfort, we do not, at least I did not perceive anything major. Ellen, what your point from a science, your point of view from a science point of view?
Inside the Earth and the space station are mostly protected by the belts around the Earth that are produced by the Earth's magnetic field, and that sends the solar wind or all those particles around the Earth, and we're mostly protected from them. What we worry about is when we send astronauts to Mars, because then they'll be in deep space, and those solar flares or coronal mass ejections, these explosions that occur from the surface of the sun, will pose much more of a risk to our astronauts. So we're studying both the effects potentially of that radiation on the astronauts, how to protect them from it, and then of course we also study the sun, trying to understand, why do these things occur, how does the sun work, and then we work very closely with NOAA, who actually does the predictions of solar weather. And it's a really interesting area. It's one we have to work on hard to make sure that we're ready to send astronauts to Mars.
Thank you, Ellen. We have a question from Toronto. We've got Artosh, who's 7. He's here with his family. He is our youngest hacker coder here, and the whole family has their own projects. So we've got Artosh to ask this question for Paolo. So Paolo, get ready.
What experiments have you done in space that can help us colonize other planets?
Good question. So that's for you, Paolo.
Well, we do a lot of experiment in space, both from a life science point of view, which means understanding how our body works, because it works really differently in space, and also from a technological point of view. We have a water purification system, we have a way to handle the food, exercise machine, this kind of thing. So we do somehow everything we do in space is related to understanding better how we work in space, what happens when we are in a microgravity environment, and understanding all of this so we can actually keep going and continue the exploration.
If I could add to that, some of the other cool things we're doing is, for example, some kinds of bacteria actually become nastier in space. Some kinds of bacteria become less virulent or less nasty. So we're actually studying the genetics of different types of bacteria. We study the genetics of plants. How does that microgravity environment change things like bacteria, and how can we use that information to maybe someday lead to some new vaccines?
Thank you, Ellen and Paolo, and thank you, Artosh. We really appreciate it. We can't wait to see his winning app by the end of the weekend, so thanks so much. I'm going to jump to Jason. This is my favorite question of all the questions. What is the craziest suggestion you've ever heard made to NASA, or the craziest conspiracy theory? Go for it.
I would say the craziest conspiracy theory is that we built a sound stage and did the moon landing here on Earth. That is the craziest conspiracy I've ever heard.
So there's a part 2 to this question, and this is from Lena in San Francisco, and this is also for you, Jason. Do you believe in extraterrestrial life?
That is a tough question. I think, Ellen, I'm not a scientist, but the scientist in me says we don't have any proof of it, and so therefore it's hard for me to say yes, there is. But the human in me, when I look and see how many planets we're discovering in other solar systems, the sheer number of opportunities for extraterrestrial life makes me believe there has to be. So scientist in me says no, not yet. Dreamer and believer in me says yes, there is.
Yeah, and I would
probably, if I could, I'd go a little farther on that one, because as a scientist, I would say we understand the conditions that were necessary or that were occurring on Earth when life evolved here on Earth. So what we do as a scientist is we say, where else in our own solar system can we find where there might have been similar conditions? And right now we have 3 great candidates in our solar system. First of all, Mars, because we know that water persisted on the surface in the past. We have under the icy crust of Europa, there's a liquid water ocean, and there's a liquid water ocean under the south pole of Enceladus, which is one of Saturn's moons. So we have these places in the solar system where we think the conditions are possible for life, and we're making progress towards going and testing those theories and finding out if they're correct or not.
Ellen, since we have you on this, I'm going to go ahead. This is a very sticky question, and because I come from the world of human spaceflight, and I'm curious to see what Paolo says about this. Here's a question from Gary in New York. How do human missions versus unmanned missions compare in terms of scientific value? Be careful with your answer.
You know, let's take the case of Mars. And first of all, I have to say I'm biased. I'm not just a geologist. I'm a field geologist, which means I think it's really important to get out there in the field on a location. And I feel when I'm out there as a scientist in a landscape, I can learn much more than maybe a robot could. But on Mars, both areas have been really important. We've learned so much from our robotic missions at Mars. We've learned the places to go to search for life. We know, again, the best targets, like the area the Curiosity rover is investigating right now. But robots move slowly, and it's hard for them to do things as quickly and as efficiently as a person could. And so I'm a strong believer that we need geologists, we need astrobiologists down on the surface of Mars, really trying to study that environment to help us determine, did life evolve? What are the characteristics of that life? So you really need both. It's not an either-or question to me.
Good answer. Good answer. Let us jump back to Guatemala City, and you have another question for us?
Yes. Hi, I'm Andres, and my question is, what has been the scariest or toughest problem you faced, and this is for Paolo, sorry, and how was it solved?
What is this toughest question that was faced by what?
What has been the toughest problem that you have faced in the mission, and how was it solved?
So who would you like to answer that question? Do you want
Paolo.
that to come from Paolo?
Yeah.
All right, Paolo.
Well, Andreas, I would pick up something that happened during the space flight on the shuttle STS-120 with Doug. We were up there, we were moving a solar array, and suddenly one of the solar arrays started tearing apart. That was a scary moment because you know, there was a pretty serious damage to the station, and it could even have blocked the path for the shuttle to leave the station. So I have to say that what happened there shows us that when we face a critical situation and when we work together, when we have the right tools, the right equipment, the right people working together, and I'm talking about Houston on the ground, we in space, all the resources, engineering, people that put their minds in there, when this happens, we can come up with really great solutions, and that was the case of STS-120. We planned an extravehicular activity with Scott Paradzinski going out in the robotic arm in something really crazy. So that was a very interesting moment. But again, while it was was a little bit on the suspense at the beginning. It showed us that the challenges put us all together, and we can overcome a lot of things if we do that.
Thank you.
Thank you. Let us jump to London. There's another question in London I could see.
Hello, can you hear us now?
Yes.
Hello, this is a question for Paolo. Hello, I'm Glenn in London. I have a question for Paolo. I'm currently researching 3D printing in low Earth orbit. How would your work have differed if large objects, which need to be folded up for launch, could be printed on site in one part?
So I think it was about 3D printing, and you wanted to know about 3D printing in space. Was that the question?
Yes, structural objects
yeah.
could be folded. Okay. It would be different if they were printed.
No, Glenn, I think this is a very good question, and I'm really looking forward for the technology to come in space. It will be extremely useful if you can just print stuff up there instead of having to bring it up there. Some of that is too big. It will be really useful if we go to another planet. I think it's about time that we come up with something like this.
Thank you, Paolo. Let me jump to Ellen now. We had a question about what are the ways that students can get involved with citizen science and scientific research at an early age to increase their interest in the science, technology, and mathematics and engineering fields?
You know, our missions have all kinds of great educational programs, from the Cassini mission to all of our Mars missions. But one of my favorite programs actually is a program called GLOBE, which involves students from all over the world. They make measurements in their local environment, studying their local environment, and we actually use that scientific data is actually incorporated in our broader studies of how the planet is changing. So again, if you're at all interested, please Google this program called GLOBE, and it's just a terrific program. And I'm looking forward to some of the apps that are going to be developed today, because I think that's another way for students to get involved, is to work with our apps.
Thank you, Ellen. I'm going to jump back to Paolo again. You're a popular guy. I have a question from Kristen in Brooklyn. She wants to know, how does being in space affect your appetite or digestion, if at all?
This is a very subjective answer, Kristen. For what concerns me, I have always a great appetite, and I really have very few problems digesting things. The body in space works really well, and I think I have absolutely no problem, except that the food, it's a little bit the variety of the food. There is a good variety, but it's not the variety we are used for. And one of the things is that we are totally missing fresh stuff. So you eat canned food or dehydrated food or something like that for 6 months. That can be a little bit not the best thing to eat. In fact, I was looking forward to come back to Earth and go and have a nice, simple, great pizza. I tried to have one ordered in space, but they would not deliver.
So, Paolo, I know that when you came back from STS-120, you were talking about the gathering, the eating was a time and a way of kind of sharing together as it's collaboration and community, which is what we're doing around the world right now with space apps. Do you remember talking about that, or how you felt about that?
No, of course, eating in space, it's a social thing, and especially if you're flying on a shuttle mission, which is a mission where things happen in really fast pace. I mean, you go on a shuttle mission and you start running like you're doing the 100 meters, and you don't stop until the mission is finished. You don't eat, you don't sleep, you don't do anything. So whenever you have a few minutes together and everybody relaxes, those are precious minutes. In space, I mean, in long duration mission, it tends to be a little bit different. In fact, in our mission, we actually managed to eat together only once a week, because it's actually very difficult for everybody to concentrate and eat at the same time in the same place. So we really managed only one time a week. But it was, again, a precious moment, a way to socialize again. You know, food is not just nutrition for the body, it's also nutrition for the brain, and we try to use this power all together.
Thank you, Paolo. So I see Deborah is back. Is Doug back with you, or is he still trying to get away?
He's still trying to get away. He got caught up with signatures, but he should be joining us shortly.
Well, so since I have you, Deborah, one of the questions we had for you is, what are the ways that other organizations can leverage the Space Apps model that we're witnessing right now, bringing people together around the world? How can we leverage that model to create innovation for citizens where they live?
Well, I think that our model right now, where we have physical locations in the 94 sites around the world, and also the virtual participants, and it's a question of not just the physical locations, but those locations actually working together. So whether that's New York developing something, sending it to San Francisco that's on a different time zone, or even to India, and having them test it, and then ship it up and send it to UK in the morning, and then have them starting to work on it. If we can think in terms of the 72 hours that this Space Apps Challenge is working on, and it's really a model that could be emulated by others. Right now we're talking with other government agencies, so I think Dr. Stoffen was talking earlier about what we had done on the climate data, and so we can use this in other scientific areas, whether that's in health sciences or some of the other aspects of work that we do, both here on Earth as well as in space. Many people forget that NASA is very involved in many different aspects. The avionics, they're involved in all of the different technologies that are for space, whether it's rocket fuel, whether it's talking about network communications and putting new laser communication devices up in space. Those are the types of things that we can draw in our other government agencies or other partners, or even the general citizens to help us create solutions for.
Thanks, Deborah. I do see there's a new face showing up in London. Do you have a question from London? Can't hear you.
Hi, my name's Eric. I've got a question for the astronauts. We're doing a space app here on the asteroid, the impact of asteroid impact on the Earth. And I was wondering about if you've experienced any micrometeorite impact on the ISS. Did you hear any loud sounds or bangs and you thought, oh, that's a micrometeorite?
Paolo, that's to you.
Yeah, Derek, a short answer is that I did not hear anything from the station or on the shuttle, but we could see impacts of micrometeorites around. We had a couple on the windows on the shuttle. We know we had some on the station. So I guess the level of noise, the background noise inside the station is such that you probably don't hear these things. This is my guess. But I never quite paid attention. But maybe.
Did you ever have the experience where you had to get on the Soyuz and wait out an incident where they were shifting station around? Was that ever during your mission?
Yes, we had a couple of occasions where from the ground they saw that there could have been a conjunction between a piece of space junk and us. So we had to actually go on the Soyuz, but we never felt anything. And by the way, we were not hit. So we never had a case of anything hitting the station. And so far, it never happened. Anything hitting the station and penetrating the hull. But there were a lot of impacts of little things. There are pictures there with the holes in the solar arrays and on the radiators and other parts of the structure.
Okay, thank you.
One more question too. Let me jump to Ellen. We're kind of running out of time. So Ellen, we do have a question about how feasible is it to create artificial gravity on a spacecraft?
It's certainly something that we're studying. We're nowhere near being able to do it, but the reason we're looking into it is because when you have a 7-8 month trip to Mars, that amount of time coming back, without gravity, there are changes to the human body that we were talking about earlier, from eyesight to bone density to muscle wasting. So one of the ideas is, could we find some way to artificially create gravity? But right now, we're not there technologically. So a lot of what we're doing up on the International Space Station right now, and why we're so excited to have, that got announced about 4 months ago, that the International Space Station is extended through 2024, that time period is critical for us to find ways to mitigate those risks to the human body from prolonged periods in low gravity that we would have on our trip to Mars. So we're really using the space station right now in important ways to get ready for that trip to Mars.
Thanks, Helen. We're going to take one more question from London, because I see we have a new person, and then we're going to take one more question to Paolo, and then if we don't get Doug back, we're going to call it a day. If you guys agree.
Okay.
So, London.
Yeah, okay. I'm John. It's a question for Ellen, but for everyone actually. So it's about the future of the ISS and its replacement. It will be not nice to have a station on Lagrangian 5 when you have a stable orbit, Lagrangian 5, and the utilization of electropulse, guys, for for the muscle, for keeping going the muscle, and also, when do you bring me to Enceladus, Ellen?
I would like to go to Enceladus tomorrow. But right now we still have a spacecraft. I'm going to start with the last part. We have a spacecraft right now studying Enceladus. Cassini is still up there. Cassini is the Cassini mission, the joint mission between ESA and NASA, is going to keep going through 2017. We're going to get more orbits, more images, more studying of those water plumes that are coming out of Enceladus. It's such an exciting, fascinating place. And I tell you, eventually we want to get back there to try to figure out, is there life under that icy crust on Enceladus? So again, it's the moon of Saturn. For those who didn't get that earlier, it's a great, terrific place. Our space station right now, we look to the future because our space station will last probably about till 2028. Right now it's extended through 2024. We think it can probably last, in good shape through around 2028. But then we're really looking to the commercial sector and say, can we turn things like the Lagrange points, low Earth orbit, over to the commercial sector so that NASA can focus its resources on sending humans into deep space, out to Mars, and maybe to study an asteroid, a piece of an asteroid that we've brought closer to the moon to study, maybe putting it at one of the Lagrange points. So there's lots of exciting things we want to do beyond deep space, and we're going to look more and more to the commercial sector, like we do now with commercial cargo, like we will in a few years with commercial crew, to really take over that area. But I'm with you. Let's go to Enceladus quick.
Thank you. See you then.
Paolo, we have one last question for you, and this is, feel free to be honest with us. Would you sign up for a one-way mission to Mars or further out?
That is a very interesting question. Who's asking this question, by the way, just a curiosity?
Honestly, there's not a name, so we'll just make it up. Joe.
I heard about this project a couple of years ago. I was in a presentation, and suddenly this guy comes up and talks about this mission. And I looked at it, and I was kind of shocked. For a couple of things. First of all, because it was one-way mission, and second, because they were trying to vote, a popular vote, to who is going to go to set foot on Mars first. And I thought both of those things were crazy. And I thought it's never going to happen. But then I start thinking a little bit about it, and it's not that when they started exploration a long time ago, when they were trying to discover America, it's not that they would buy a return ticket. I want a return ticket to I don't know, the Caribbeans and back. It didn't work like that. Most of the people did not know where they were going, and most of the people, frankly, did not come back. So that's what exploration is. You're not you're going to do something that you don't know. And actually, this mission here, it's an interesting thing because you're going to Mars, and people assume you're going there and dying, but in fact, you are living there the rest of your life. Which, if you think a little bit about it, it's not. I don't think is really out of this world. It's such an interesting thing. I even had the idea that I should volunteer for this mission actually. So it's good. The other thing about selecting through a popular vote the person that would go there. This also sounds strange, but don't we vote for our president? And isn't that more important than maybe who goes to Mars first? And we vote for the president, but we think it's a crazy idea if we vote for who's going to Mars. So I think we need a change of mentality a little bit. We need to go back to explore, to dare to go where nobody goes, and we don't know what is going to happen. This is what exploration is. We should go back there.
And NASA, we've actually started talking about pioneering. Instead of exploring, because pioneering, you know, especially really implies you're going somewhere to stay and to settle, and that's how we like to think about Mars. I agree with Paolo.
Thank you all. I'm going to give you a quick round, and we're going to let you speak. Oh, go ahead.
No, just 1 second. I think I see Jason's there on the little picture, and to me he looks like an alien there. I'm pretty sure he answered the question about the aliens before. He's an alien. Look at him. He has antennas coming up from his head.
We can draw those behind him. I'm going to do a quick round robin and go to each one of our guests and let you have a closer remark. So we're with you, Paolo. Let's start with you. Just a few hello, goodbye remarks.
I think Ellen there summarized it really well. I mean, we need to pioneer again. We need to go back in the spirit of doing things that are unknown, and that's what exploration is. We should not be afraid of the future. We should just go ahead and get it. I think this Space App, what you guys are doing with Space Apps, with the Global Challenge, with citizen science. They are all very good activities, and so I'm just happy to be here, to be a little part of this project. We should go back to go where nobody goes and do a lot of other things.
Thank you, Paolo. And I want to do a special shout out to Erica Rolfe at ESA, who enabled you to be here. So she's awesome, and we love her. Thank you so much. Let's jump to Jason, Mr. Alien now.
Another sweet title. Thanks, Paolo.
Oh, this is awesome. You're never going to live it down.
The list grows. So great to be able to hang this afternoon, particularly for my first time to be at a location. The Space Apps is such an incredible success. I look to last year's Space Apps, where the Gotham Lab folks in New York are building a small sat based on ideas that kind of sparked at Space Apps last year, and seeing a company grow from that kind of beginning. I'm so excited to see, with all these asteroid challenges and the other challenges that we have this year, to see what comes and continues to grow. So thanks to everybody for continuing to participate and spread the good word. We will prove we are smarter than the dinosaurs.
Let me jump to Ellen next.
You know, we have big challenges in front of us, whether it's, you know, serious challenges like climate change, how do we adapt to our changing planet, to exciting challenges like how are we going to pioneer Mars. And NASA can't do this alone. We need everybody to come along with us. And this Space Apps Challenge, to me, is such a great example of how we do much more when we do it together. And I think this is tremendously exciting today. You guys are doing great work, and I can't wait to see the apps that come out of this.
Thanks, Ellen. And Deborah, our awesome leader.
Well, I'm sorry that Doug and I had to step out. We had another activity. But I wanted to thank everyone for participating in this activity. I did like what I heard when I came back. Pioneering, I think, is the way to go. Innovation is the way to go. Having 93 locations around the world is what's going to make it happen. It is that true collaboration and putting everyone's heads together to solve these big challenges, and they are big. We don't know all of the answers to get us to Mars. We don't know all of the issues that are going to be addressed, whether that's in materials science or the engines or stuff that we will encounter as we do our asteroid missions, and then how the Earth itself is changing. And I think that's why pulling all of these different sciences together is really going to shed that light, and using the tools such as Grand Challenges and Space Apps Challenge, getting as many people involved in this mission as possible will take us to that next generation that will get us to Mars. So again, I thank you very much, and thank you to my colleague who kept our little hangout going, and we look forward to some great solutions today and tomorrow.
So I also want to thank you all in Toronto and the Ontario Science Centre for letting us host this awesome Google Hangout from here. And can you guys give a shout out from Toronto? All right. Woo! All right, thank you guys, and I look forward to the judging that's tomorrow, and then seeing all of your awesome apps come forward to our global judging, and we want to see you at the SpaceX launch, which will be next September, and that launch takes a resupply mission up to space station, so we'll let you be part of human spaceflight at that one, so you better be winners. So let's just get going. Thank you, guys.
Thank you all.